Let's get into today's content. So this will be part two's video if you're watching the YouTube playlist. So we're talking about input, output, and files. So it's not always just necessarily um, input and output always going to a file. Sometimes we have to think about it like it's going in our input stream or our output stream. Remember we talked about, if I annotate here, we talked about our buffer stream, which, if you enter the user's the numbers, the user enters the numbers, 1, 2, 3. Oh my goodness. Wish my drawing was better. That's the number 1, 2, and 3. And then it will always put a new line character at the end of the buffer. So this is, saved in our input buffer, right? Because we're reading that from our C in or our C out, will be like that string of text that we want to output. And usually we have a new line on that as well. So just keep that in mind. Input, output, and files. We're not always necessarily talking about files. I'll also talk about buffers and streams. And we'll get into that a little bit later in class, but I just wanted to remind you how that buffer stream works. Okay. So actually, I think I want to start with this one first. I labeled the PowerPoints wrong. We're going to start with number 22. So that's why I was talking about the buffer stream, because we're talking about streams and files. So we use those streams to communicate with our files, and then after that I'll talk about input output with files specifically. So we're going to start with number 22. I labeled them incorrectly, so I will fix that after. That's 21, and make note of that. That is going to be 22. Okay, so here's a little visual for you guys with input and output stream. So we have our program running, and when we ask for input from a user, usually it's typically connected to the keyboard by default. It'll come through that input stream here, and there again is that little, there's the buffer stream if that's 1 and that's a 2. I can't draw that small 3. Say a 4 was going into that box right here. And then we've got like space for your new line. Now our output stream, it's very similar, it's the same thing, but it's just going out to the screen. And this is typically by default going to the console. You can hook this up to go to a GUI, like a graphical user interface or something like that. But by default, this is going to go to the console and display text to the user that way. All right. So when we're doing IO stream manipulation, and manipulation, what I mean by that is being able to format the stuff that comes into the input stream or format the stuff that goes out into the output stream. There's a couple things that we need to include in our header, those preprocessor directives, right? The pound include or the hashtag include. And the most common ones that we use is the IO stream by default. And remember, we always have used that one for C in and C out because we're using our keyboard. And that provides the definition for the formatted input and output from and to streams. There's the F stream header file, which is formatted input and output for file streams. Okay, so that's a little bit different because it's going from our buffer to a file instead of to the user on the console. And then there's the IO manip header file, which basically provides definitions for manipulators used to format that stream. Okay, so that stream, when I'm talking about stream here, I'm talking about these things. We're going to format them before they're displayed to the user, or we're going to format them when they're coming from the file. We're going to format them before they come into our program, right? So when we manipulate stuff, it's happening to the stream itself. So you kind of have to imagine or envision it like that. It kind of helps helps you understand what's going on in the process behind the scenes. But the IO manip is going to be stuff for formatting those streams, input and output. When you see IO like that, that's what that means. Okay, so some of those classes, the commonly used classes when we include those headers or those preprocessor directives is the iOS class, which provides basic support for formatted and unformatted input and output operations. So the iOS class, input output stream is what it stands for, iOS, not like iPhone iOS. But basically you can use iOS ::app to append stuff to a file instead of just overwrite it, because you'll overwrite stuff by default. Okay, so that's an example of the iOS class. The IF stream stands for input file stream class, or the OF stream, respectively, stands for the output file stream class. It can be a bit confusing because it looks like if stream or of stream, but it's actually stands for the high-level input operations on file-based streams, and then for the OF stream, it's high-level output operations, okay? Then Fstream, okay, this one's a bit of an interesting one. It provides high-level I/O operations for file streams for both input and output. So it does both. So if you want to do both, it might actually be the best choice. Then the last one here is the string stream, which we'll talk about at the end of class more so, but it can be really powerful for using memory-based strings. If you don't want to save something into a file, but you still want to manipulate input and output operations in a memory-based string before it's passed to the user, then you can do it in memory instead of in a file. And it's coming from the input string stream or the output string stream class. So there's also an I string stream and an O string stream, just like there was an IF stream and OF stream for files. Okay, so handy to remember those ones. And then some of our global stream objects, we've got our classic cin and cout, which is, connected by default to the keyboard or the console, which is our standard input stream or standard output stream object. And then we've got cerr and clog, so standard error stream or standard log stream. So if you ever wanted to do logging or display an error to the console, then you can use cerr instead of cout. Cool. Okay, so stream manipulators. What do I mean by a manipulator? Well, we can actually manipulate the spacing or the formatting or the width of certain elements as they come in through our input stream or our output stream. So there's a bunch of different or useful member functions that we can use to control the formatting, and it can be used on both input and output. All right. The time of the effect on the stream varies. So what I mean by that is basically the set W here, it only affects the next stream item. All right. But some of them are persistent. If you set a flag for something, like a set fill is another type of formatting, and it will fill empty spaces with whatever character you put in. It's persistent and it will stay like that for the rest of the life of your executable file. So if you set the fill to an asterisk, then every empty space will set to an asterisk until you put it back. Whereas the set width 10 will only set the width of the next item to 10, but then after that, everything else will just go back to default. So it doesn't stay persistent. So you can use it as a member function as well as a manipulator. So here we're using the member function doing cout.width. You'll see usually we're going to just use the manipulator set w. So you can do it both ways. Both are fine. It's more popular to do it the manipulator way because it's still keeping the cout with the greater than less than signs or the extraction or insertion operators, just because that's what we're used to. Okay. All right. So let's start with some Boolean formatting, okay? So I'm going to show you some formatting for Boolean, for integers, and then for floating point numbers. So for the very first one, we're going to cover Boolean. So by default, Boolean will show as a value as 1 or 0, which is totally fine, and we can use that to compare things programmatically pretty easy, knowing that it's going to be 1 or 0. But we can also format it to show as a string, as true or false. And sometimes that's more appropriate. If we're displaying it back to the user, then it saves us all of that code as a programmer to say, like, if it's 1, then print true. Then we can just print the value of the Boolean instead. We can just print, say we had a Boolean variable called isAlive. Then we could just print cout isAlive, right? And then we don't actually have to print, if cout equals 1, then print true. So by default, it'll display 1, 0, but if we wanted to change that, then we can use what's called the bool alpha flag, okay? And you can do bool alpha or no bool alpha right here, and I'll just annotate that. So The no bool alpha is the default setting for Boolean displays, and it's 1 or 0. But if you say cout bool alpha, then everything after that, this is persistent, so this will last for the rest of the life of your program, then everything after that will display the strings true or false. Okay, so if you wanted it to display true or false, but then you want it to go back to displaying 1 or 0, then you have to use the no bool alpha flag again. Okay, so this one's persistent. It's important to remember that. Cool. There's also a method version. So like I said, we can use the method version as well instead of just appending it to our cout insertion operator. And so the method for it is .setf, and then you can pass, obviously if you're using namespace standard and namespace iOS, then you don't need to include those. But if you aren't using the namespaces, then standard iOS bool alpha or standard iOS no bool alpha. You can also use the reset iOS flags, the input output stream flags, and it will reset everything back to default. Okay, so then it would basically reset back the bool alpha flag to whatever the default is. Cool. All right, so that's Booleans. Now let's talk about integers. So by default, we show integers in base 10, which is what we learned in school, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But there is other bases, right? Computers use base 2, which is binary, ones and zeros. And then there's also hexadecimal, which is, I believe, base 16, which represents, a location in memory or something. And then hexadecimal is when you have like FF, X, whatever, and it's all this wonky looking stuff. Anyways, if you want to show integers in different bases, then you can do that. You can show that in the stream manipulator. You can do formatting to it. And some of the common ones, if you want to show base 10, we have the DEC flag. If we do no show base, then that's a prefix that's used to show if it's hexadecimal or octal. No uppercase, so we can show all our hex values in upper or lowercase if we want, or there's no show pause or show pause, which will show a positive symbol in front of positive numbers. We always show a negative symbol for negative numbers, but sometimes there's no positive symbol for the positive numbers, so we can show that. So here's some of those, just as an example here, using the base 10, using hexadecimal, base 16, or octal, which is base 8. And just the corresponding outputs of what it would display. So the base of 255 would be FF, and the octal version would be, I think, 277, not actually 377. But we'll probably rarely ever need to do that. Just helpful for you guys to know about this. Cool. Now, show base and no show base will basically show what base we're in. So it can be very easy to forget if we're base 10 or if we're base 8 or base 16, and these things will stay persistent through the life of your program. So if you say you want to be base 16, if you want to be hectal for the rest of your program, then everything's going to be showing, FF whatever, and it's going to be all crazy numbers. But if you do show base, this will also be a persistent flag, and everything that has a number will now show the base. So we see the prefix here 0x in front of the FF. That's the prefix for hexadecimal. So we know that's a hexadecimal number. So we know that we're in base 16. Now, if we see a 0 prefix on every single number, then we know that's the prefix for octal. So if you forget what base you're in and you want to just see, you can just do the show base flag, and then you can turn it back off. Another manipulator for integers is uppercase. So say we have hexadecimal code, our FFs, if we want them to be all uppercase, we can just use the uppercase manipulator flag, and then everything will be uppercase. Same thing with the show pause and no show pause. We can show our positive integers. You can see in the first example, by default, that 255 has no positive number there or positive symbol right here, but our negatives will by default. If we do show pause, then we now show our positive symbols. Cool, and then you can reset all of your flags or reset back to default using the following, reset iOS flags, and then passing the base field, show base, show pause, uppercase flags, and setting them back to default if you forget what your defaults are. Cool, and then the last one I want to cover for formatting is floating points, since quite often they have a lot of digits after the decimal point, and it's really helpful to know how to format to a certain number of precision. Okay, so some of the methods that we'll use commonly when we're formatting floating point numbers is the set precision. So by default, that's 6. So it's the number of digits displayed. So it's before and after the decimal. It's the total number of digits displayed by default is 6. If you want that to be less or more, then you can change the set precision number. Fixed and not fixed is a flag that basically will allow it to be a specific number of digits after the decimal point. So you can have it fixed to 4 decimals only after the decimal point, or not fixed, and then it will just go all the way. The no-show point is a flag that allows trailing zeros to be displayed or not displayed. So if you had the number 12.3400 and you wanted to show the 2 last zeros, then we can use the no-show point, and that will force trailing zeros. The no uppercase or uppercase, again, if we're displaying in scientific notation and we want uppercase or not uppercase. And then same with the no-show pause or show pause flags. Cool. Also, these affect all further output, so it's important to remember they're persistent. Okay, so they will affect all further output to the stream. So if you do any of these flags for the rest of your program's life cycle, it will be affected by these flags. So the first one is the precisions. So by default, we have 6. And you can see here, if we count 1, 2, 3, 4.57, it's taking this number here, which has 8, 1, 2, 3, 4, 5, 6, 7, 8, and it's going to round them to a precision of 6. 1, 2, 3, 4, 5, 6. Okay. Now over here, if you have a really large number, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0.987654321, and by default it's going to be 6, it will use scientific notation. It will still show 6 numbers here, 1, 2, 3, 4, 5, 6, and round it, and then it will display scientific notation times 10 to the power of 8, right? Now, if we wanted to change that precision, and we use the set precision flag. So we can do set precision 9, and then this will take 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers, and we'll actually round it. See how it's if you actually read this number out and put commas in here and here, it'd be 123,456,789. This is rounding it up to 123,456,790. So it's rounding these last two because the precision is set to 9. So it's going to round to the 9th precision point. Okay, now the fixed flag, okay, we can use fixed or not fixed. The fixed flag, oh, where did I go? Here, can set the precision after the decimal point. So this is everything just after the decimal point. So for set precision, that's everything in total, starting from the most prominent number, which is the most left-hand side number, which is the 1 in this case. The fixed flag starts from the decimal point, and we can do fixed, and by default, it will be 6 places from the decimal. So here we'll show 1, 2, 3, 4, 5, 6 up to the 4th number there, and then it will discard the 3, 2, and the 1. Now, if we wanted to set precision to 3, but then use scientific notation, so we can use the scientific flag or method there, and it will display the precision to 3, 1.23 times 10 to the power of 8. Okay. To force trailing zeros, so say we had a number here like 12.34, and we wanted to display it to show 4 decimal places no matter what, because all our other numbers go to 4 decimal places after the decimal. Even though it's zeros, we can force those trailing zeros by using the show point flag, and it will just add the zeros to the 4th decimal point. Here, we can see here, 12.34, there's no trailing zeros. Here we can set the trailing zeros to specific precision. So I think somewhere else we would have set our precision to 3 or to 4. It's not shown in this code, but it will go to whatever precision you set it to. So I don't know if the precision set, that's what I was looking for, but it's not actually in there. Cool. And then returning back to the general settings or the defaults, we can use the reset iOS flags and then just put the float field flag in there, and we'll reset all the stuff for floats, okay? And the C++ docs have really good documentation for all of this, setting and resetting flags. There's a bunch of others if you want to look at them. These are the most common, but you can always find these in the PowerPoints here or look them up. Now, for formatting streams, okay, so that's formatting different types of values, so ints, floats, and booleans. If we want to actually format our streams, okay, so our input and output streams coming from the keyboard or going out to the console, we can do a lot of different formatting. So think about it like a text document, like you would with your Microsoft Word. You can have like align left, you can have centered, you can have right justified, you can have certain widths or tab page, not pagination, but tabs or tabation, if that's a word, tabbing between certain widths between each element in the buffer or in the stream. So some of the most common manipulators we have is the set W, the left, the fill. Left is also when there's no field width, then it's left, and it's default right when we are using field width. So if we do the set W method, everything by default will go to the most right space in the stream. By default, if there's no field width set, so if we don't use the set W method, then it will go to the most left field in the stream. And I'll show you what I mean by that in a second. Some of these, it's important to know, only affect the next data element on the stream, okay? Some of them are persistent, like the fill, but some of them are only for the next element, like set W. Okay, so set W only applies to the next item in the stream. It's not permanently setting the field width. So here we have each item setting a field width of 10. So you can see here, if this helps you visualize it, I've got a bunch of numbers going across 1, 2, 3, 4, 5, 6, 7, 8, 9, and then that 0 can be a 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we've got, breaks every 10 spaces. So we've got 4 kind of columns we're working with. Now this first variable num that I set up here to 1, 2, 3, 4, 4.5, 6, 7, 8, I'm setting a width of 10. And when we use the set W manipulator, remember I said by default, it'll go to the most right-handed side it can in its field width. So it has a field width of 10, which is what we expect, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, but it's at the most right-hand side of that field width. So it's lined up with the 10th element here, and then it goes from that over. Now, the hello string also has a set width of 10, and it's at the most right-hand side of its column that it can be at. And same with this one here. Okay, and then we can see there's nothing after that, so it's just empty. So hopefully that makes sense. Now, if we don't set a width, you'll see, I'll show you that example right now. We've set W to 10, and then we've set it to left, because by default, it goes to the right. So we've set num here, and the set W of 10 will only affect num, because it only affects the next element in the stream. So num here has a width of 10, so we can see it takes up the entire 10 wide column here going up to the 0. But we've left justified it, so it's going to be lined up on this side. And then we can tell that the hello obviously doesn't have a set width, it's not right justified or anything, so it's just going to start at the next element right after, which is the 1, and continue on from there if this is the buffer stream, right? So that's how the set W works. So you can set width to each element if you want things to be evenly spaced apart, and then you can set the justification using the left or the right alignment flags. Cool. The set fill flag is persistent, and it applies to all items in your stream. And if there's no width or empty characters, then there will be no fill, okay? So as we can see here, we set a W, a width of 10 on our num variable, and it's going to be right justified because there is no alignment after our set W up here. And the set W only affects the next element in the stream, which is num, and it's a set W of 10. So it's going to take up all 10 going down here to there, which is what we expect, and it's right justified by default. The set fill method will fill all empty spaces with a dash, which it does here. We've got 1, 2, and 3 dashes. But it's important to note that if there is no empty characters or width set for an element, such as hello, because the set W was only on the next element, then there will be no set fill either, because there's no empty spaces here. There's going to be no dashes, right? If this hello had a set width of 10 and it started over here, then these would be dashes, right? So the set fill is a very handy method to keep in mind too. And it is persistent. So here we can see we set fill to an asterisk, and then we set the width to 10 on our num variable. We set the fill to be a hyphen, and then we set the width of 10 on our hello, and then we set a width of 15 on our hello. But notice we didn't call set fill again, but it's still printed all of these dashes in the 15 wide column that we created because it's persistent, all right? So even though we didn't set the fill on our 4th line of code, we still see those dashes because there's a set fill that's persistent. All right, so we've got our asterisks, then we've got our set fill from this, but then because there's empty spaces between these hellos from the set W of 10 and 15, we're going to be filling those empty spaces with hyphens. All right, so that's it for this PowerPoint. That is stream manipulators. I'm going to stop the recording there before we get into files. See really quickly what I've got in the code. Yeah, I don't have any examples for that. It's pretty straightforward stuff. You guys can practice this if you want in CodeLight, and the PowerPoint is available on Blackboard. We're going to get into file input and output next, so that'll be the next part of the video. We'll take a little bit of a break here. I'll end the recording.